What I'm going to tell you no to any dealership in the area is going to please. Do you see that row of trucks in the shop that look like spaceships, with screens larger than my television and paint that shines like gold? They are not there for an oil change. They are there because their owners, hard-working people who trusted in the television advertisements of 2024, realized that they bought a problem with four wheels. As a mechanic who has spent 30 years seeing how metal surrenders before bad design, I tell you that we are in the worst era to buy a pickup. The brands have stopped competing for who makes the most resistant chassis, and now they compete for who puts more useless sensors in an engine that no longer can more. In 2026, the second-hand market is going to be plagued by these traps, and if you do not want your bank account to end in the scrapyard, pay attention. This is the technical autopsy of the giants of paper. Ram 1500 with eTorque engine. The Ram 1500 always has been the queen of comfort, but with the introduction of the eTorque system, they crossed a line that no respectable mechanic wanted to cross, that of unnecessary electrical complexity. The eTorque system is not a hybrid that allows you to circulate without spending gasoline. It is, in technical terms, an electrical crutch of 48 volts. The great sin of the engineers of Stellantis was to eliminate the traditional alternator, that simple piece that anyone can change with a wrench of 10 mm, and replace it by a massive motor generator coupled to the belt of the engine. This component not only charges the battery, but also assists the crankshaft and manages the stop and start system. The problem is that this generator is exposed to everything that a work truck must face: constant vibrations, extreme heat of the block, and the worst of all, contamination by dust and water. When the eTorque system fails, the truck does not simply spend more. Because the network of 48 volts manages a large part of the power electronics, a failure in the generator can leave you without power steering in the middle of a curve, or cause that the braking system loses its electronic assistance. In my shop, we have seen units where the cost of the replacement piece, only the generator, exceeds $1,800. But that is only the beginning of the disaster. The lithium battery of this system is hidden behind the back seat. If you live in a warm climate, that battery cooks slowly. In 2026, with these units already out of their limited warranty, the average owner will face bills of $5,000 only so that the truck again starts. Toyota Tundra. This position hurts me especially because Toyota used to be the gold standard. The V8 engine of 5.7 litres of the previous generation was literally a piece of eternal engineering. We have seen units with 1 million kilometers without opening the block. But in the new Tundra, Toyota succumbed to the pressure of downsizing and mounted a V6 of 3.4 litres with 2 turbochargers. The result has been a catastrophe of reliability that has stained the name of the brand. The most infamous failure resides in the electronic actuators of the relief valves or wastegates. Due to a defect in the manufacturing of the materials of the actuators, these stay stuck in open or closed position. If it stays open, you lose all the pressure of the turbo and the truck feels slower than a car of 3 cylinders. If it stays closed, you risk an overpressure that can blow the pistons. But here is where this becomes a horror movie for your pocket. In the Ford or Chevrolet trucks, changing a turbo is a heavy but accessible job. In the Toyota Tundra, the engineers decided that the turbo should go in a position so tight against the chassis that there is no physical way to put a hand to work. The manual solution of Toyota to change an actuator of $300 is to perform what we call separation of body and soul. One must disconnect all the electronics, the brake lines, the steering column, and lift physically the entire cabin from the chassis with an industrial elevator. We are talking about 35 to 40 hours of labor. For 2026, when these trucks start to show this common failure out of warranty, the joke will cost you between $6,000 and $7,000. And not only is it the turbo, the crankshaft bearings in the units of 2022 to 2024 are failing massively due to a problem of cleanliness in the casting of the blocks, leaving metallic remains that destroy the engine inside. Toyota is replacing entire engines today, but in 2026, the one who will have to replace the engine with his own money will be you. The problem of the actuators of the relief valve, wastegate in the Tundra is not only a software failure, it is a crisis of thermal fatigue of materials. The electronic actuators are situated in a zone of the engine bay where the airflow is almost null, what causes that the internal components of plastic and tin solders reach temperatures of crystallization. When the actuator fails, the computer loses control over the boost pressure, what generates a decompensation in the air-fuel mixture that can raise the temperature of the head of the pistons in matter of seconds. Chevrolet Silverado, GMC Sierra. If you want to see a grown man cry, ask an owner of a modern Silverado about his valve lifters. General Motors has been years trying to perfect the dynamic fuel management (DFM) system, which allows that a V8 engine works with only 2 or 4 cylinders when there is no load. The problem is that to achieve this, they need some hydraulic valve lifters that are ridiculously complex and fragile. These components depend critically on a perfect oil pressure and an absolute cleanliness. However, the design of the system causes that the oil degrades faster in the channels of the lifters, what ends by making that the internal mechanism collapses. When the lifter collapses, the pushrod stays loose and starts to hit against the camshaft like a jackhammer. In my experience, it is not a matter of if it is going to fail, but of when. We have received trucks with only 15,000 kilometers with the engine destroyed. When the lifter fails and scratches the lobe of the camshaft, the repair implies opening the engine completely, removing the cylinder heads and replacing the camshaft, what supposes a bill of $4,500 to $5,000. But the most outrageous thing is that, due to the lack of supplies, General Motors has been installing the same defective pieces as replacement, creating an infinite cycle of visits to the shop. In 2026, these trucks will be pariahs in the market. No one who knows about mechanics will want a used Silverado with the active DFM system. The only real solution is a delete kit that annuls the system, but that annuls the warranty and, in many places, is illegal for emissions tests. It is a truck that forces you to choose between destroying the engine or breaking the law. The architecture of the valve lifters in the engines of General Motors suffers from a vulnerability called oil aeration. The dynamic management system requires that the oil acts as a hydraulic fluid of precision to lock the pins of the lifter. However, due to the design of the oil pan and the high revolutions, the oil can trap microscopic air bubbles. The air, unlike the oil, is compressible. This causes that the lifter does not lock firmly, generating a mechanical impact of metal against metal thousands of times per minute. Ford F-150 PowerBoost. The Ford F-150 is the most sold vehicle of the United States, and the PowerBoost version was presented as the jewel of the crown. A truck with an electric motor of 47 horses integrated in the transmission of 10 speeds. But the reality in the shop is that Ford has created a monster of complexity that its own technicians sometimes do not know how to tame. The principal problem is the integration of the software between the V6 biturbo combustion engine and the electric motor. The owners report jerks so violent during the transition of power that it seems that someone has hit you from behind. These hits are not only annoying, they are destroying prematurely the internal clutches of the transmission of 10 speeds, a box that already by itself is known for being problematic. But the true financial danger for 2026 is the cooling system of the high-voltage battery. This battery is mounted under the chassis, exactly in a zone where it receives all the punishment of the road. Stones, salt water in winter, and the scorching heat of the asphalt in summer. The connectors of the cooling system have shown leaks, and if the coolant enters in contact with the lithium cells, the battery stays unusable. Ford asks close to $8,000 for a new battery. Also, the regenerative braking system is linked in such form to the hydraulic system that if there is a minor electronic failure, the brake pedal changes its travel and firmness in unpredictable form. Imagine going down a mountain pass with a trailer of 4 tons and that your brake pedal suddenly feels like a sponge because the software of the PowerBoost decided that there was a communication error. It is a truck that tries to do too many things at once and does not finish doing any with the reliability that a worker needs. The complexity of the PowerBoost resides in its management of combined torque. The permanent magnet electric motor is sandwiched between the combustion engine and the transmission, eliminating the traditional torque converter for a quick disconnection clutch system. The physics behind this design is extremely demanding. The software must synchronize the revolutions of the gasoline engine with those of the electric motor in milliseconds so that the coupling is smooth. When the temperature sensor of the battery coolant detects a deviation of barely 5 degrees outside the optimal range, the system alters the times of hydraulic pressure, causing those violent jerks that the owners compare with being rammed. Number 11. Nissan Titan. The Nissan Titan is the example of a good product that was abandoned by its own creators. Nissan has announced that 2024 is the last year of production of this truck, and in the automotive world, that makes it an orphan truck. Buying a Titan so that it lasts you until 2026 and beyond is a financial suicide for a reason that goes beyond mechanics, the logistics of survival. When a brand discontinues a model that already by itself sold little, the generic piece manufacturers stop producing spares immediately. If you have a small frontal crash in 2026, you could spend 6 months with the truck stopped because there is no fender or a headlight available in the entire country. Mechanically, although the V8 engine of 5.6 litres is robust, the 9-speed JATCO transmission that they introduced recently has had serious problems of temperature management. In towing conditions, the fluid degrades at an alarming speed, causing that the changes become erratic and that the box ends by slipping before the 100,000 kilometers. But the final blow is the resale value. In 2026, no one will want to buy a truck of a brand that no longer makes it and from which it is difficult to get spares. You will stay trapped with a vehicle that depreciates at 20% each year and that the independent shops will reject because Nissan does not release the technical information necessary to repair its body control modules. It is a truck condemned to oblivion, and you do not want to be the one who pays the bill for its burial. The collapse of the Nissan Titan in 2026 will be a case study on obsolescence by corporate abandonment. The V8 engine of 5.6 litres uses a high-pressure direct injection system that is extremely sensitive to the quality of fuel. With the discontinuation of the model, Nissan has reduced the updating of the injection maps that correct pre-detonation problems in rear cylinders, especially the cylinder number 7, which tends to overheat. By not having continuous engineering support, these engines will start to suffer from misfire failures that the independent mechanics will not be able to diagnose easily without the Nissan consultation software, which each time will be more difficult to update. In terms of structure, the use of specific alloys in the chassis for the crash tests of its launch year makes that structural repairs require controlled atmosphere welding. Jeep Gladiator. The Gladiator is, visually, the coolest truck of the market, but under that adventurous facade there is hidden a mechanical fragility that should give them shame. The greatest scandal of the Gladiator involves the versions with manual transmission. The design of the clutch pressure plate is so deficient that it cannot dissipate the heat in effective form during an intensive use, like when starting on a slope or doing off-road. This has caused that the pressure plates literally explode, throwing fragments of hot metal that pierce the transmission bell and cause fires in the engine bay. The solution of Jeep was a software update that reduces the power of the engine when the system detects heat, which is like putting a band-aid on a bullet wound. It does not fix the mechanical problem, it only hides it at the cost of your performance. To this we must add the infamous death wobble or bamboleo de la muerte. Due to its solid front axle design ideal for the field but problematic for the road, the steering components like the steering damper, the ball joints and the control arms wear out prematurely. At 80 km per hour, a simple bump can make that the entire truck starts to vibrate so violently that the driver loses control of the steering wheel. In 2026, the second-hand Gladiators will have fatigued steering systems that will cost more than $2,500 to rehabilitate. It is a truck that is sold as indestructible, but that requires a constant and expensive preventive maintenance to not become a danger for public safety. It is an aesthetic whim that will ruin you if you try to use it as a daily vehicle. The physics of the clutch failure in the Gladiator is a matter of insufficient thermal mass. The clutch disc is too small for the inertia that must brake a vehicle of 2 tons with tyres of 33 inches. By trying to perform a towing or rock climbing maneuver, the generated heat exceeds the dissipation capacity of the cast iron pressure plate. This extreme heat causes an unequal dilation that ends by fracturing the material. Upon braking, the centrifugal force throws the pieces through the aluminum casing of the transmission. The fire risk is real because those pieces exit at temperatures superior to 500 degrees centigrade, cutting lines of fuel or electric cables nearby. Rivian R1T. The Rivian R1T is a feat of electrical engineering, capable of accelerating faster than a Ferrari and of wading deep rivers. But it has a fatal defect that makes it one of the worst purchases for the near future: its repair architecture. Unlike a Ford or a Chevy, where the cargo box is a separate piece that can be removed with 8 bolts, the Rivian uses a monocoque side panel of aluminum that goes from the front door to the rear light in a single continuous piece of metal. This is a nightmare of insurance and costs. Real cases have been documented where a slight hit on the rear corner, something that in any other truck would cost $2,000 to fix, resulted in a bill of $42,000 in the Rivian. Why? Because the damaged piece cannot be replaced. One must cut structurally the truck and weld new aluminum panels, a job that only shops certified by the brand that charge plastic surgeon rates can do. In 2026, when the insurance policies for these trucks skyrocket due to these costs, having a Rivian will be prohibitive. Also, the electric motors are integrated in the propulsion units in such form that a bearing of $100 that starts to hum will force you to change the entire propulsion assembly for $7,000. It is the iPhone of the trucks, beautiful and powerful, but designed to be discarded or so that you pay fortunes for any minor repair. The Rivian R1T challenges the law of modular repairability. In a body-on-frame truck, the impact is absorbed and is dissipated through programmed deformation zones that are replaceable. In the Rivian, being a structure of extruded aluminum and integrated panels, the impact travels through the entire skin of the vehicle. The unique side panel acts as a structural reinforcement. If it wrinkles, the torsional rigidity of the entire truck is compromised. Aluminum, unlike steel, has a limited memory. Once it bends, trying to straighten it weakens the molecular structure of the metal, increasing the risk of fatigue cracks. Therefore, collision centers see themselves forced to replace gigantic sections, which implies dismantling the battery pack of 800 kilograms to avoid that the heat of the welding damages the fuel cells. Honda Ridgeline. The Ridgeline is the favorite of automotive journalists because it drives like a car, and that is exactly because it is a car. By being built on the monocoque platform of the Honda Pilot, it lacks the rigidity of a real body-on-frame chassis. For 2026, the Ridgelines that have been subjected to what Honda calls truck use, towing and loading weight regularly, will show a worrying structural fatigue. The monocoque body starts to suffer from excessive torsion, what causes creaking noises in the cabin and permanent misalignments that no suspension shock can correct. The iVTM4 all-wheel drive system is excellent for snow, but its internal clutches are not designed for the stress of pulling a heavy trailer out of a boat ramp. We have seen rear differentials burned before the 50,000 kilometers because the owner believed in the towing capacity of 5,000 pounds that the manual says. The cost of replacing this differential is of $2,000, and if you do not change the special Honda fluid every 15,000 kilometers, the warranty will wash its hands. Also, the multi-link rear suspension has so many bushings and articulation points that, as soon as you start to load weight in the box, the wear becomes exponential. In 2026, buying a used Ridgeline that has had a tow ball installed is buying a vehicle with the chassis tired and a transmission on the edge of the abyss. It is a truck for people who do not need a truck, and it will ruin you if you try to treat it like one. The Ridgeline suffers from what we call fatigue stress in unified chassis. By not having an independent frame, the engine and the transmission are mounted transversely, what concentrates the weight and the traction effort in the front engine mounts. When you tow 5,000 pounds, the traction effort is not transmitted in linear form through 2 steel rails, but is distributed through the entire sheet of the body. This generates micro-movements in the spot welds of the roof and the pillars. With time, this translates into water leaks and torsion noises impossible to locate. Mitsubishi L200 Triton. The Mitsubishi L200 has been during decades the symbol of resistance in the most hostile conditions of the planet, from the mines of the Andes to the deserts of Africa. But its last technical evolution, forced by the strict Euro 6 norms, has introduced a Trojan horse in its system. The post-treatment of gases through AdBlue, liquid urea, and the diesel particulate filter, DPF. The mechanical problem is a matter of basic chemistry. Urea is an aqueous solution that, before changes of temperature or periods of inactivity, tends to crystallize. In the L200, the urea injector is located in a zone of the exhaust that not always reaches the self-cleaning temperature in short journeys, what causes that salt crystals form that obstruct the system. The financial disaster begins when the differential pressure sensors detect this obstruction. The computer of the truck enters into a state of electronic panic and activates a protocol of startup lockout. An alert will appear on the dashboard indicating that you have 800 kilometers before the vehicle no longer turns on. I have had clients that, for living in rural zones far from a dealership with the original software, have seen how their work tool becomes a piece of furniture of 2 tons. The cost of replacing the AdBlue tank module because Mitsubishi, in its infinite wisdom, decided that the pump and the sensor cannot be changed separately amounts to almost $3,500. To this add that, if the particulate filter gets clogged completely due to failed regenerations, the bill goes up another $2,500. It is a truck that punishes you for using it in short journeys or for leaving it stopped, turning the legendary reliability of Mitsubishi into a distant memory buried by defective urea sensors. In 2026, the used units of this model will be a risky bet where the exhaust system is worth more than the engine itself. The crisis of the L200 in 2026 will center on the crystallization of urea by static evaporation. The AdBlue injection system uses an ultrasonic nozzle to atomize the liquid in the exhaust flow. However, when the engine turns off, a small quantity of urea stays in the tip of the nozzle. If the truck is used in zones of low humidity, or if the diesel fuel has a sulfur content slightly superior to the permitted, a crust of ammonium cyanurate is generated. This crust blocks the return pressure sensor, sending an error signal to the ECU that interprets that the pump has failed. Volkswagen Amarok. The Amarok Phi 6 is a marvel of German engineering. It offers a torque and a smoothness that make any other truck seem like an agricultural tractor. But here the golden rule applies: the greater the refinement, the greater is the fall. The 3.0 TDI engine is an interference design, what means that the space between the open valves and the piston in its maximum point is non-existent if the timing fails. The weak link here is not only the timing belt, but the accessory belt, the elastic that moves the alternator and the air conditioning. By a design error in the timing protector, if the accessory belt breaks or frays due to the entry of a small stone or abrasive dust, the remains are sucked toward the interior of the timing cover. When this occurs, the timing skips barely a couple of teeth and the engine commits suicide. The valves hit against the pistons at 3,000 revolutions per minute, bending stems, breaking rocker arms and often cracking the cylinder heads. In my shop, repairing a V6 engine of Amarok that has suffered this collapse costs close to $12,000, almost the cost of a new engine. The maintenance is so critical that if you pass barely 5,000 kilometers of the change interval, you are living on borrowed time. Also, to perform any intervention in the front part, we mechanics must dismantle the bumper, the radiators and the front cross member, what adds 20 hours of labor to any simple bill. In 2026, with the dealership rates through the clouds, an Amarok Phi 6 with more than 100,000 kilometers that does not have a maintenance history documented with surgical precision is a financial hand grenade with the pin already removed. It is a truck for who can afford the luxury of German maintenance, not for who needs a vehicle that forgives neglect. The true Achilles heel of the 3.0 TDI engine is the thermal hysteresis of its timing system. In the shop, we have observed that the accessory belt not only fails due to external agents, but by the loss of elasticity of the automatic tensioners manufactured in light alloys that deform microscopically after 50,000 kilometers of cycles of intense heat. Upon losing tension, the belt starts to vibrate at a frequency that coincides with the harmonic of the engine at idle, what facilitates that it derails and is sucked by the crankshaft pulley toward the principal timing. Also, the Amarok uses a system of hydraulic valve lifters that depend on a constant laminar flow of oil. When the engine turns off, the oil drains from the upper galleries. If the oil does not have the exact viscosity, norm 57.01, when starting in cold a dry hit of milliseconds is produced. Multiply this impact by 1,000 starts and you will have valves with fatigue of material ready to break at the minimum misalignment of the belt. Chevrolet Colorado, GMC Canyon. General Motors has given a technological leap with the new Colorado and Canyon, equipping them with a turbo engine of 4 cylinders with an impressive torque. However, in their eagerness to imitate Tesla, they committed the error of centralizing almost all the vital functions in the central infotainment screen of 11 inches. In these trucks, the screen is not only for the map and the music, it is the interface for the air conditioning system, the all-wheel drive modes, the towing configuration and the exterior lights. The technical problem resides in the video and data processing module, which lacks an adequate heat dissipation system for the temperatures that the dashboard reaches under the sun. For 2026, the massive failure of these screens will be the complaint number one. When the module fails due to the degradation of the solders by thermal cycles, the truck becomes practically inoperable in comfort conditions. You cannot turn on the defroster, you cannot change to the low mode of the transfer case, and you cannot see the reverse camera. The replacement piece is a sealed unit that costs $2,800 and requires an online programming that only the dealership can do, charging you another $500. The real users already are reporting that the screens stay in black or restart in the middle of the highway, what causes dangerous distractions. It is a design that ignores ergonomics and durability in favor of digital aesthetics. Buying one of these pickups is to accept that your capacity to drive at night or under the rain depends on that a tablet of mid-range does not decide to freeze. In the real world, physical buttons save lives. In the Colorado of 2026, the lack of them will ruin your budget. The vulnerability of these trucks lies in the multiplexed network architecture that connects the central screen with the engine control module, ECU, and the body control module, BCM. It is not only that the screen turns off, the problem is that the CAN, Controller Area Network data bus, saturates when the screen processor enters in an error loop due to overheating. Upon saturating the bus, the priority signals like the activation of the air conditioning compressor or the change of traction mode are put in a waiting queue. This generates a delay or operational lag that can make that the truck does not respond on time when you try to activate the descent control on a steep slope. Ford Ranger. The new generation Ford Ranger is a capable truck, but carries a heavy technical cross: the 10R80 transmission. This box of 10 speeds, designed to optimize fuel consumption, is a piece of excessively complex engineering. The problem is not the number of gears, but the internal hardware. The bushing of the rear oil pump has a tendency to slide from its original position, what causes a drop in the hydraulic pressure of the clutches. When this happens, the transmission starts to perform erratic changes, especially between the third and the fourth, and the seventh and the eighth gear. In the shop, we receive Ranger with barely 40,000 kilometers, whose transmission oils already smell like burned. The software tries to compensate the loss of pressure, increasing the slip time of the discs, what generates an excessive heat that ends by cooking the internal rubber seals. A complete reconstruction of this transmission in 2026 will exceed $6,000. The most frustrating thing is that Ford has launched multiple software updates, but none can fix a problem of physical tolerance in the bushings. If you are testing a used Ranger and you feel a dry hit upon putting it in reverse or a delay when you accelerate to the floor, withdraw from the sale. That is the unequivocal sign that the 10R80 is wounded to death. It is a shame because the rest of the truck is solid, but a pickup with an unreliable transmission is like an athlete with a knee of crystal. In any moment it will leave you stranded when most you need it. The 10R80 transmission suffers from a physical phenomenon known as fluid cavitation in the valve body. Because it has 10 gear ratios squeezed in a reduced space, the galleries through where the hydraulic oil flows are extremely thin. When the transmission operates under towing load, the fluid reaches flow velocities so high that they create vacuum bubbles. Upon collapsing these bubbles, they erode the aluminum walls of the valve body, creating internal pressure leaks. This pressure loss is the one that causes that the clutches of the fourth and fifth gear do not engage with the necessary force, causing that slippage that ends by burning the friction material. Tesla Cybertruck. The Cybertruck promised to be the vehicle that would change the industry forever with its ultra-hard, cold-rolled stainless steel. But the technical reality has been a brutal reality check. The first great problem is metallurgy. The stainless steel of the Cybertruck does not have a layer of paint or transparent varnish. Although stainless steel does not rust like common iron, it is extremely susceptible to environmental contamination. The particles of iron in the air or the salt that is used on the roads for the ice adhere to the surface and create small points of galvanic corrosion that look like rust spots. Cleaning this requires special chemical products and a constant manual effort that no truck owner wants to do. But the most serious thing is safety and reparability. The Cybertruck uses a steer-by-wire system. There is no physical steering column that connects the steering wheel with the wheels. While there are electrical redundancies, the failures in the steering actuators already have caused massive recalls. Also, its structure is composed of enormous pieces of aluminum casting called gigacastings. In a traditional pickup, if you damage a rail of the chassis in a slight accident, it can be straightened or a section can be replaced. In the Cybertruck, if one of these castings cracks, the truck is structurally unusable and must be declared total loss. In 2026, the insurances for this model will be the most expensive of the market, and the resale value will sink when the buyers realize that they have a vehicle that cannot be repaired in a conventional body shop. It is a whim of Silicon Valley that ignores a century of automotive engineering lessons about flexibility and durability. The Cybertruck faces a challenge of pitting corrosion that materials science explains in clear form. The 300 series stainless steel, by not being painted, depends on a passive layer of chromium oxide to not oxidize. However, in industrial or coastal environments, the iron or chlorine particles break this layer. Toyota Hilux. To speak badly of the Toyota Hilux seems a sacrilege, but my duty as a mechanic is to tell you that the myth of indestructibility stayed in the 20th century. The modern versions of the Hilux, especially those equipped with the 2.8-litre turbo diesel engine, have suffered enormously due to the emission systems. The diesel particulate filter, DPF of Toyota, has been the object of class action lawsuits in several countries. The problem is that the regeneration system fails in burning the accumulated soot. What causes that the filter gets clogged completely. When this happens, the back pressure of the exhaust gases affects the turbocharger, causing failures in the variable vanes. But the darkest problem is the oil dilution. When the truck tries to regenerate the filter injecting extra diesel in the exhaust stage, part of that fuel does not burn and runs down the walls of the cylinders until the oil pan. I have seen engine oils in modern Hilux that have a 10% content of diesel. This destroys the lubricating capacity of the oil, what leads to a premature wear of the bearings of the crankshaft and of the camshaft. In 2026, many Hilux that have been used principally in the city or in short journeys will have tired engines with only 100,000 kilometers. Repairing the injection system and the filter costs about $4,500. Toyota has launched software updates and a manual regeneration button, but that does not change the fact that the engine is suffering internally. The Hilux no longer is the truck that you could neglect. Now it is a machine that requires a constant attention to not die by its own exhaust system. The fall of the Hilux is due to an error in the combustion kinetics of its new piezoelectric injectors. These injectors operate at pressures of up to 2,500 bars and perform up to 5 micro-injections for each explosion cycle, Ram 2,500 to 3,500. We arrived at the position number 1 of the infamy. The heavy-duty Ram with the 6.7-litre Cummins engine is capable of moving mountains, but between 2019 and 2024, these trucks were equipped with the Bosch CP4 high-pressure fuel pump. This pump is a masterpiece of efficiency but has a fatal design defect. It depends exclusively on the lubricity of the fuel to not self-destruct. The diesel in many regions of America is dry and has little content of sulfur, which is what lubricated the old pumps. Without that lubrication, the internal rollers of the CP4 pump start to turn outside their axis, generating a metal against metal friction that pulverizes the steel. When the pump fails, occurs what we call in the shop the metallic massacre. The pump throws billions of micro-shavings of steel through the entire injection system. These shavings destroy the 6 injectors, the high-pressure fuel rail, the return lines and contaminate the fuel tank. The repair bill in 2026 for this disaster is around $17,000. Yes, you have read correctly, almost the price of a new compact car. Although Ram has made recalls for some models, thousands of trucks continue circulating with this time bomb under the hood. If you are looking for a used Ram in 2026, you must ensure that there has been installed the conversion kit to the CP3 pump, the old and robust version. If it does not have it, you are buying a pickup that can turn your savings into metallic scrap in any moment that you load a diesel of bad quality. It is the most expensive engineering disaster of the current market and the reason why many independent transporters have ended in ruin. The Bosch CP4 pump is the most expensive engineering error of the history of modern pickups for a reason of basic tribology. The design of this pump uses a roller that slides over a lobed cam. In Europe, the diesel has natural lubricity additives. In America, the refinement process to eliminate the sulfur eliminates also these lubricants. Without that microscopic layer of oil between the roller and the cam, a phenomenon of cold welding by friction is produced. The roller locks for 1 millisecond, the cam hits it, and chips of case-hardened steel are torn away. Here ends our dissection of the mechanical disasters that await you in 2026. As you have seen, the high price or the famous brand does not guarantee that the truck is going to last. We are in an era where complexity has surpassed reliability and where the informed owner is the only one who survives financially.